All right, welcome back. So this is the second video in building a circuit here in Tinkercad. And this would be the same if you're building an actual breadboard. It's an awesome simulation that lets us build and practice without potentially ruining some components that can happen when you're actually building. So it's good to start here. I teach this Project Lead the Way class, Principles of Engineering, and we're gonna learn about breadboarding. And before we do our lab, we're gonna do this simulation. And what I'm actually going to use is, instead of the simulation assignment, I'm going to use the physical assignment, since I have a breadboard and resistors, and I'm just going to build exactly what the physical assignment would look like, and then you can build the physical assignment later in person. So I've gone and I've connected my positive to my positive leads on my breadboard, and I've jumped from that positive end down to here. Now, if I'm creating my circuit right here, let me click back to the assignment. My circuit is going to look something like this right here. So I've got positive or power coming in here, and then it goes around and it connects to a resistor of 330 ohms. This symbol means that I have an open switch, so that would be my push button switch, and that leads over to what's called a diode or an LED. And we'll talk about that. And then this V is when we talk about measuring, and we'll focus on that at the end. And then the LED connects all the way back to my negative side of my power. So if I go back to my circuit design, I'm going to bring in, the next thing was a resistor. So I'm going to bring in my resistor. It's right here. Before I connect anything, I'm going to make it 330 ohms. So 330, change this value to ohms. And if you notice, when I do that, the color bands on here change. So all of those bands have signifiers. We're not going to worry about that right now, but that's how you can tell the difference between resistors. These different colored bands tell you colors. So what I'm going to do is I'm going to connect one end to be my positive end and the other end to be my negative end of my resistor, or my next end of my resistor. So I'm going to connect, since I jumped down into this column, the one end has to at least be in this column as well. And I could do any of these holes, because then this end is connected to this wire in any of these holes. Now, since I'm kind of running out of space, the other thing I can do is I could jump down, and to spread out your breadboard, it's kind of nice. I could jump down and I can jump across. So then I'm bringing power. Now I'm connected into this column, and I'm also now bringing power down into this one. So I'm down here, and I could just make a nice big loop and space things out so it's easy to see. So here's my resistor, 330 ohms. Now I need my push button, and how a push button works is it goes from the left side to the right side. So power comes in the left side, and when you push the button, it comes out the right side. And that's the same with the bottom two terminals. So it's kind of like these two terminals would be kind of connected. These two terminals would be kind of connected, and power goes from here across to here. So I'm going to put my push button. Again, I can kind of put it wherever I want. And for the sake of our simulation, even though there's not a hole down here, I can just put it in there. And I'm going to put, this side is connected to here. And now when I have push power, it would come out this side. So I'm going through the push button. And if I go back to my simulation, if I go back to my schematic, I go from the resistor now over to my my push button switch. And then from the push button switch, I go to my LED. Now, this is building it sideways, and I'm building it vertically, but I'm still doing the same thing. I'm coming in from positive, down, and I'm going to come around this way. So I just have kind of turned it. So you can think of turning your head sideways, and you would be seeing the same thing as the schematic, basically. So now on this side, in the same column that I've got this hooked into, I need to hook in my LED. Now the thing about LEDs is, if you look at this, an LED is considered a diode, which means current can only flow one way. It can only go from this side down through this side. So with an LED, we have what's called a cathode or an anode. The cathode would be your positive side, and the anode, or excuse me, the anode is the positive side and the cathode is the negative side. And so we need to make sure the cathode ends up being the side that continues towards our negative end. So on here, if I look, the cathode is set up on the left right now, and the anode is set up on the right. So if I hook this in, my LED will not work because it's going through the cathode to the anode, but I need to flip it around so that it goes the other way. So what I'm going to do, and this is the one thing I don't really love about Tinkercad, is I can flip this right here. So I click the rotate, and I click, and it kind of goes up, I don't know, maybe 30, 15 degree increments, probably, something like that. Oops, I went too far. I'm talking. I just want to flip it upside down. So now my anode is facing up, and that's going to connect in to here. And if we want to make it even clearer so it's not covering up our switch, I could put this right up here. And now this is connected in this column, so I can jump a wire from here to spread things out, and that still completes my loop. And since I'm coming out maybe the negative side, I could make that black. So I've completed my loop here, and I've connected now up from this spot to this spot. Jumper wires just help you space things out so it's easier to see. So I would recommend maybe trying to use that. And then I'm going through my anode to my cathode, and then my cathode, if you look back in my schematic, my cathode then right here will connect back to the negative side of my circuit. And so I'll connect from here back up, and I could go anywhere in this black, even if it's not right here. I could connect back up to the black right here, maybe make that black one more time, and I have a completed circuit. I have a closed loop now. Everything is connected. So if I start my simulation right here, I've got this set to 9 volts, and when I push my button, the LED turns on. It does give me a warning, tells me that I'm pushing the limits of my LED, but it does work, okay? So we'll talk about measurement in the next video because I'm getting a little long here. So there's your built circuit, and next we will talk about measurements.